If you walked into a mill tomorrow, what is the first thing you would look at regarding the overall blade setup?
The first thing I would look at is, does this machine have a cleaning doctor? Is the cleaning doctor in use? And what condition visually is that cleaning doctor in? And that will tell me a lot about that machine very quickly.
Welcome to Inside Tissue Manufacturing. Today we'll be talking creping with Mike Six. Mike, welcome to the show.
Hey, Rob, thanks.
Hey, I wanted to ask you first, how did you become involved with creping?
So I went to school in Stevens Point for paper, and then right out of college, got hired by Cadent, and my first role was an applications engineer for tissue, and it was basically the one person in the field that was helping to launch our new, at the time, 24 years ago, long life creping blade bimetal material called ProCrape. And I just lived immersed in tissue then for the next several years.
Could you start out by talking about why creping is so fundamental to tissue quality?
Yeah, I mean, creping is a unique thing. You know, when you talk about a doctor blade, usually they're cleaning a roll, they're removing water from a roll, but a creping blade is literally a blade that makes the product, and it makes it by creping the sheet off of the dryer. You know, the sheet impacts the blade, pops off the dryer, bonds between the fibers are broken, which creates bulk for absorption. It creates crepe, which is gives you your surface hand feel softness. And yeah, you're basically creating a product by creping. Where when you talk about doctoring or doctor blades, so that none of them, any other application has anything like that big an impact on the product.
Okay, I'd like to get into a little bit on the fundamentals of what actually happens during the creping process.
Yeah, you can see the sheet impacts the blade. The adhesion between the sheet and the Yankee fails. The sheet pops from the dryer, actually kind of blows away from the dryer briefly, and then re-impacts. And each time the sheet re-impacts the blade is what gives crepe. And each impact actually, like I said, it destroys some of the fiber to fiber bonds, and it that allows for bulk, which is the absorption of the paper product, and the crepe defines the feel of the surface. So if you're making facial tissue, you want something that is very soft, and that is probably the most important thing. And absorbability is important, but is probably going to take the back seat to softness. So you're going to want something that crepes very finely, lots of fine repeated impacts of the sheet on the blade. So you're going to have chemistry that locks the sheet to the dryer a certain way, and a blade with a certain bevel of a certain thickness to produce more finer crepe. And then if you're making, let's say, paper towel, kitchen towel, the softness at the surface is going to be less important, and the amount of bulk, the ability for that product to absorb is going to be more important. So you'll probably do fewer crepe bars, and just more destruction of the sheet, essentially, to create more voids between the fibers to allow that tissue paper in the form of paper towel, kitchen towel, to absorb better.
In terms of the blade itself, what would you say is going on mechanically during the creping process?
Yeah, for the blade itself, and
Hmm.
And you and I spoke earlier. One thing that's shown on this slide is a tappy tip number. I worked with a really fine group of people from all over the tissue industry, and it's a really good all-encompassing tip on Yankee Doctor operational guidelines. Any user of a Yankee that crepes should take a look at this tip. But this image down on the right and on the left shows, a new steel blade and then one that has got some wear time. And uh, this surface here is the surface that's against the dryer. And as the blade wears from new to over time being used, that wear pad will grow. And so that's mechanically what will happen to the blade. It essentially wears. And a lot of people really focus on this wear pad, both the angle of it and the width of it. But the other kind of wear you get on the blade is actually impact wear on the creping shelf or creping table, the top of the blade where the sheet is actually impacting, where the sheet hits the top of the blade as it comes around. And this has a big impact on sheet quality over the life of a creping blade too. If the furnish you're using causes lots of erosion of that tip, your bulk is going to climb, the quality of your crepe bars is going to go down. So if you're making kitchen towel, that's not so bad. But if you're making a product like facial tissue for the consumer market, this kind of erosion of the blade tip is going to cause you to probably go out of spec by having bulk climb to a number that's too high and require a blade change.
Hmm.
And as this kind of wear, the sliding friction wear, that's going to change the pressure of the blade against the dryer. This corner is a very small surface area, so your 15 to 20 pli of loading pressure is concentrated on a very small area. So this corner of the blade is going to dive deep down into the chemical coating on top of the dryer. But as the blade wears, that surface area increases. Your PLI remains the same, but the PSI that's just distributed to the surface of the dryer will go down for each specific area. So you essentially will be more at the surface of the coating. The coating will have more opportunity to get hard, and there's then more opportunity for things like chatter to
Hmm.
start developing.
Hmm.
So those are the two real big mechanical things that are happening with the blade, the sliding wear and the impact wear from creping tissue.
Yeah, no, that's very interesting. I do have a question for you. So, personally, I've spent a lot of time as a process engineer on a tissue machine and would regularly measure the wear angle as
Mhm.
well as the width of the wear pad. What I wanted to talk
Yeah.
about was the impact wear that you talked about. Are there certain grades that see that, or is it usually present on all grades?
So this kind of shelf wear will be present on any kind of creping. Let's say you're making a recycled furnish grade for the away from home market, where it tends to be a lot of debris carried along with the furnish.
Mm-hmm.
The rate of wear on the shelf due to impact will be higher. If you are using a steel blade, the rate of wear due to impact will be higher. If you're using a hard ceramic tipped blade, the ceramic does protect this area, so that rate of wear will be generally lower. I've actually seen that CERMET blades, people talk about ceramic creping blades, and usually they put them all into one big category, ceramic. And there's actually within that, there's more technically known as CERMET, and then the blade that's more technically described as ceramic. And the CERMET material blades are usually applied using a method that makes the material more dense and more homogeneous. So while the hardness of that material may be lower than ceramic, because of the way the material is put onto the blade, the shelf wear rate can actually be among the lowest, which was surprising when I started seeing that on blades. And
If a process engineer operator, should they be concerned about that shelf wear, and how can they look for it, and how would it impact them negatively?
yeah, I mean, it's not something you'll ever see with the naked eye, and you can see this kind of wear, the sliding wear on a steel blade, especially with the naked eye. Um, but typically, you'll see the end result of this kind of wear. So this is, essentially a zoomed in. This is the shelf, the top of the blade, and you can actually see you've basically kind of worn like a divot into the top of the blade, and it almost looks like a ditch.
Hmm.
And that basically means the sheet, instead of impacting and quickly popping off of the tip of the blade, dives into that, and it takes longer for it to uh, pop off the blade, and so the quality of your crepe gets eroded. Your bulk that's one of the reasons bulk climbs as a blade wears, especially a steel blade. So a good indicator that you're getting shelf wear is um, observing by paper testing on the top of each reel, in a lot of cases, that your bulk has climbed. And typical manufacturers will typically, have upper lower limits for bulk or caliper, and when you start exceeding them, is a good indicator you have this kind of wear and you're due for a blade change.
And then just overall with creping itself, is there anything that you find surprises people just about the creping process?
No, not like a surprise, but I guess a thing that people don't consider is blade change cycles. You're going up and down, and the quicker that it happens, the harder it is for the converting operation or rewinders to have predictable success. And a lot of folks on the machine don't consider that.
Hmm.
They also then don't consider how uh, blade trials or chemical trials or whatever, anything that results in better, more consistent blade life can be really positive for those folks and make their life way easier, because the sheet properties are more stable. Like, the quicker your sheet properties fall off the cliff, the harder it is for the folks on the back end that are converting that paper to be efficient.
Oh,
And that's the thing people don't really think about a lot of the time, I think.
that's a really good point. I think it's if you're in manufacturing, the importance of talking with your counterparts in finishing, converting, and find out what's impacting them, and what you can do. Because in the end, we're all on the same team. We want to make a great product for our customers out there. What I'd like to do, Mike, is shift gears a little bit. I have a high speed video of the creping process. I'd like to share that and have you talk it over a bit.
All right, yeah. So this is a really cool video in super slow motion of creping actually happening. Um, you talk about how the sheet impacts the blade and pops off and kind of folds over on itself, and you can literally see that as it's coming off the blade. The other thing you can see is, you talk about the bonds of fibers actually being exploded and breaking. You can see it's driving fibers and fines actually out of your sheet from that breaking of the fiber to some of the fiber to fiber bonds, and that creates dust, and that could be a major issue in machine hygiene. A lot of folks that have worked for a lot of years in and around creping operations have seen, the kinds of fires that can happen very quickly when paper dust ignites. So, and it's also, if you're making a consumer grade product, having lots of dust that travels with the sheet through converting to the end user, it can create a real negative experience for some of the end users of consumer grade tissue having a lot of dust. So, it's just really interesting to see how that happens. And, this looks to be a somewhat fine crepe, and you can see dust being created. You can see the sheet. You can see the sheet on the dryer barely. It's extremely thin, but then you've created bulk. The bulk I'm talking about, you can see how the sheet is now essentially wider in terms of thickness because of the creping process.
Okay, thank you. That was a fascinating look at what we're talking about here.
That's a cool video. Stuff like that is hard to come by, and it's really a good illustration for people to see.
That footage makes the interaction really look extremely dynamic. It's not something people would ever see real
Yeah.
time on the tissue machine. But one of the variables people frequently discuss is blade angle. And how important is the actual blade angle? And what advice would you give a mill for establishing and maintaining the correct angle?
There we go. Here's a generic image that shows, all the different geometries and the terms that are used. But in terms of blade angle in general, it's important that every grade, every machine, every product should have a target blade angle. And you probably want to be plus or minus 1 degree from that target. You want to be consistent across the machine. You should be checking your Yankee Doctor setup. You should check it for sure once a year thoroughly.
Hey,
And
excuse me, Mike.
yeah,
Just one thing I want to clarify. When you talk about a blade angle, are you talking about the grind angle of the blade, or can you explain that a little bit to make sure we're all clear?
yeah, no, thanks. Like, so this image, you can see essentially this curve is mimicking the surface of the Yankee dryer. And you can see what most people would call your blade angle is that angle that is from the tangent line to the edge of the blade. And basically, so that's your angle, and that's what you measure when you use a blade angle gauge. You would put it up against the tip of the blade, zero it, and then put it on the blade itself, just below the bevel. And that angle that you're measuring by doing that is this angle shown here, your Dr. blade angle. Um,
Okay, and that will, if there's any flex, depending on what the loading is, that takes all of that into account, and you're looking at a true blade angle. Is that a good way to say it?
yeah, and so you want the most accurate way to measure real blade angle. Obviously, the machine needs to be down, everything needs to be done in a safe manner, but you'll measure it with. I prefer, if possible, to have some steam in the dryer so it isn't cold, so the doctor has some heat in it, and you're going to have a new doctor blade loaded at your normal operating pressure with your normal operating stick out, which is the distance of the blade is out from the top of whatever supports it and whatever type of blade holder you have. Yeah, measure the angle that way. Some people will sometimes call the shelf angle or the bevel angle at the tip of the blade. They'll call that the blade angle, and really that's the bevel angle, the bevel on the tip of the blade. If it was just a square shape here, it would have a 0 degree bevel or a 90 degree bevel, depending on the terminology used in each mill. And this blade you can see has got an angle that's defined here, the blade bevel angle. Here's the flat surface, if it would be there, down to here. And so that is your blade's bevel angle. And all these things, the blade, Dr. blade angle, the blade bevel angle, they all work together to create your impact angle. Um, and basically the the greater your shelf angle or impact angle, you'll have a more open pocket is a term that's used. You know, the bigger this is, the more open your pocket is, which means it's easier for the sheet to come off the tip of the blade. You'll be you'll be doing more fine crepe and less, you know, more micro crepe, less macro crepe. So you'll have a softer, nicer feeling sheet that's less bulky. And the smaller this impact angle is, the more you close up that pocket, you'll get a coarser crepe, a more harsh crepe quality, but also more bulk will be generated. So if it's a product where you want the ability to absorb more easily, that is a positive
Hmm.
sheet property. And so these things can be manipulated. Uh, you can change the blade angle or the bevel angle and achieve the same result and impact angle. And it's a lot easier to
Hmm.
manipulate your blade's bevel angle, because that's just take a blade out and throw a different blade in with a different bevel angle to change your impact angle.
So,
Um,
yeah, from a practical term, if a machine is grade changing from facial to bath, or maybe they even make towels, typically, what do you see in the field? Is it simply at grade change you're going to change the blade grind angle, or is it a combination, or what do you see out there, Mike?
Yeah, I mean, the typical thing is if if a mechanical change is necessary to create the product you want when you change grades, if you have a swing machine making facial all the way to towel, it's likely that, when the machine is making facial tissue, your bevel angle here will be perhaps, 75 degrees, or uh, 15 degrees down from 90. Uh, just That's just a generic statement. And if you're going to go to making towel, you may need to take that blade out and put one in that has essentially no bevel on it, a square edge, a 90 degree, a 0 degree. The terminology will vary based on the facility, and that will close up your impact angle pocket, and you'll get more bulk and less fine crepe. But some machines are able to dial things in and maybe run something in the middle, maybe a 5 or 10 degree blade, and then manipulating real speed and the weight of the sheet, they're able to achieve their goals for sheet properties without needing to run a different blade bevel angle. Typically, if people need to make a mechanical change quickly, you're going to change your blade bevel angle to help produce a different sheet property in terms of
Okay.
softness.
So if you walked into a mill tomorrow, what is the first thing you would look at regarding the overall blade setup?
Well, the first thing I would look at is, does this machine have a cleaning doctor? Is the cleaning doctor in use? And what condition visually is that cleaning doctor in? And that will tell me a lot about that machine very quickly. The doctors other than the creping doctor, and if there isn't a cleaning doctor, I'd probably look up at the skinning doctor or the cutoff doctor. The doctors other than the creping doctor often will get ignored, and if I walk into a facility and I can tell the hygiene is really good on those doctors, um, the Yankee surface looks really good in terms of the chemical, the look of the chemical on the dryer before it picks up the sheet. I know I've walked into a place that spends a lot of time taking care of their doctors in general. So that means I'm likely to find that the conditions of their creping doctor are going to be good. If I see doctors that are loaded with dust and debris, with a blade that's sticking out higher on one end than the other because the blade holder never gets cleaned out or the blade never gets changed, um, I know I'm likely going to find some issues. The other thing I look at when I walk in the door for the first time, if it's a machine that has a blade holder that has edge fingers. Um, this is something I picked up years ago from John Holton. A lot of us in the tissue industry know John Holton well. He's a guru when it comes to Yankee, you know, Yankee cylinder services. He worked for them all, and he knew it all. And he basically said, if I'm coming in and I'm dealing with a Yankee that has edge wear and I'm grinding it, and the edge fingers on the doctor look like this, I know I'm going to be back. And if they look like this, um, then I know I likely won't be back for repeat visits. So the other thing I look at, I took that as a personal challenge, is hygiene of edge fingers. This apron is very important. It prevents debris from packing in behind the edge fingers. And if debris is allowed to pack in behind edge fingers, it puts localized pressure on each finger that is not desired. And that pressure can cause edge wear on the dryer. And it can cause, rather significant edge wear that's also rather localized, which can really cause issues. And, if you've got a machine with lots of edge fingers, for whatever reason, a lot of the machines that come through European OEMs, they come with lots of edge fingers. And if you're getting really close to the sheet edge, and in some cases, there's some older machines where the fingers actually get into the sheet, that having a poor hygiene, poor setup of your edge fingers can really play havoc. And that's something you can see visually while the machine's running without having to get out a dial indicator or blade angle gauge. So those are the things I look at when I go into a mill that will tell me this is what I'm walking into. This is sort of the base status of things in this facility, or just on this individual machine.
Fascinating. I think you've touched on a very important topic here. Something that I want to ask is, how do we get our machines to look like on the left? The edge fingers are nice and cleaned. Is it regular maintenance? Is it a philosophy? Can you talk a little bit about that and what you've seen works out there?
Any critical piece of equipment in the paper industry needs regular preventative maintenance. And if you ignore something, it will eventually cause problems. Let's say hygiene of your blade holders, no matter what type of blade holder it is. It could be an air tube loaded holder, a holder loaded with pucks, a holder that's got a round metal bar in it, a holder that's got a liquid tube in it. It needs to be kept clean in the interior, because if it isn't, eventually what happens is your blade doesn't sit evenly in the blade holder. It's tilted essentially, and then you have different blades stick out on one end of the machine versus the other. You can develop chatter because of that. You can develop chop because of that. Edge fingers that are not kept in good order, especially if there's lots of chemistry involved, and dust and debris can cause edge wear. So just regularly blowing out the holder on blade changes on the down day, getting in there, getting it clean. I have some customers that basically, I should go back to that. They on a down day, they keep an extra set of edge fingers, and on the down day they slide the edge fingers out, they clean the cavity out, and they have a new set ready to go with a nice, that's been cleaned up, that has an apron that's intact, and they slide it into place. It's a very quick process. And if they need to do something with the set of fingers they took out to get it cleaned up, they can do it between outages, and off they go. They have a clean, properly functioning edge finger setup at that point. When you slide edge fingers out, you're not affecting their settings. Their settings are defined by the position of these profile screws. Those don't move when you slide out the edge fingers assembly themselves. And they slide right out of the edge of the holder. Um,
Yeah,
and
I was going to ask you that if somebody's taking all the time to dial in their edge fingers and they do that, but what you're saying is you're not going
no
to
effect
lose that.
on the settings. No.
Hmm.
The profile screws that are used, there's sort of two philosophies that are used. In Europe, the philosophy is to use just a standard set screw with like a lock nut on it, and that basically goes over the end of it, and it locks it into position. That works. It's kind of clunky. I don't love it. Um, the method that Cadence Solutions uses, at least, is we supply screws that have a dab of nylock on them, and that nylon thread locker essentially keeps the profile screw from moving position unintentionally through vibration. Um, Profile screws, no matter who provides the holder, um, they, you don't want to just use a standard stainless set screw. Over time, they can come loose through vibration. Um, that was an interesting story. Back in the old days, Cadent, when we sold profiling screws, we didn't necessarily describe them very well in our quote.
Hmm.
So it wouldn't be unusual for a customer just to assume this is a stainless set screw, and gosh, these guys are charging a lot of money for it, because we also plate it to keep it from galling. And I had a customer install just a bunch of stainless set screws, and we profiled the holder, and everything went great. And like 4 days later, they're like, "Oh my God, what did you guys do? Every single profiling screw is loose, and we're having all sorts of havoc." That's when we figured out that shame on us, we didn't describe the
Hmm.
product in our quote very well, so they didn't realize that it wasn't just a simple set screw. And
Hmm.
shame on them, they bought a set screw, didn't tell us what they had done, and so it just kind of all came together to kind of create some chaos. And that mistake, thankfully, hasn't been made since.
Okay, no, that's good story. All right, well, we could shift a little bit into blade materials and talk maybe a little bit about steel versus ceramic, when each is appropriate. You know, I've got some other questions, but let's just talk in general a little bit about blade materials.
Yeah, I had just a little generic slide put together. There's actually a lot of different blade materials that are used in creping. There are folks that use stainless steel to crepe.
Hmm.
It's pretty rare. It's typically going to be a 420 stainless steel, but I have seen some exotic grades of stainless steel used. Stainless is definitely only safe to use on a cast iron Yankee surface. Um, the One of the more common materials used is steel. It was the vast majority of all uh, creping blades used, and there's still people that crepe with steel. Um, there are different grades of steel. So if you're a user that has a cast iron surface and you're going to metallize, you should be careful that you're buying a grade of steel, if you're going to continue to use steel in any of the positions, that is appropriate for a metallized dryer.
Hmm.
1075 and 1074 are too soft.
Hmm.
There's a risk of what is in the tissue industry called micro welding that can
Hmm.
happen, which is essentially a combination of adhesive and abrasive wear due to material incompatibility. Essentially, if the blade's too soft, it starts to uh, degrade and embed itself and pull material out of the metallization. Uh, and metallized surfaces are a work hardened material. And so a metallized dryer is more uh, um, prone to a micro welding incident than a cast surface.
Hmm. Hmm.
So you need to be careful. And you should consult with the provider of your metallization. They will have guidelines on what blades are acceptable, and some have guidelines on what blades should never be run. And my experience tells me stainless steel should never be run on a metallized dryer. 1075 and 1074 should never be run on a metallized dryer. 1095 should be okay.
Okay.
Um,
Hey,
but
Mike, I'm sorry. Go ahead.
I was just going to say quick that
Yeah.
not every supplier of steel blades identifies the grade of steel.
Mm,
So sometimes they'll interchange different materials. You might get 1095 this time, you might get 1074 that time.
mm.
But if you ask them, hey, I specifically need 1095, everybody can do that. You just need to be clear that that's what you need so that that's what you get.
Okay, and I'm very interested in this question. I've been involved in a dryer that was metallized, and I've heard the term used generically blue steel. And I wanted to ask you, is blue steel just kind of a general term, or does it refer to one of the grades or some of the grades we just talked about?
I don't know enough to know that if there's a technical term that is identifying, a 1095 or not 1095. To me, blue steel, carbon steel, it's a generic catch-all for anything from 1074 to 1075 to 1095. So, um,
Okay, so it's very important to specify, and you said the difference between the 1074, 1075 is that they're softer than the 1095. Is that right?
yep, that's, I mean, there's, metallurgy behind it, but essentially,
Sure.
yes, they
Okay.
are softer. A softer material is not good against a metallized surface and can increase the risk for microwelding. And of course, microwelding is only going to happen if you have bare metal blade to metallized surface contact for an extended period of time that the blade gets hot. That
Hmm.
should never happen because you should always have your spray boom on, which should always be putting out chemistry under the dryer. Microwelding is very rare, but it has happened.
Oh,
So because of that concern with metallized dryers, more and more people turn to ceramic blades, a harder blade material. A harder steel material is going to be less likely to microweld. Ceramic, because it isn't made up of metal, the ceramic that's against the dryer is incapable of microwelding. So if your main concern is I have metallized my dryer, I want to never have any concern about microwelding at all. I'm going to run only a ceramic blade in all of the positions, not just the creping position. Um, and that's a decision that some manufacturers make to protect their investment. And I think it's especially important if you have a steel Yankee dryer. In today's world, it's getting almost impossible to buy a cast iron Yankee
mm,
dryer. I think there's one, maybe two foundries still doing it that can be trusted. And so more and more steel Yankees are coming. Steel Yankees have to be metallized. You can't make tissue off of a raw steel surface. So if you damage the metallized surface on a steel Yankee or wear through the metallized surface, you're dead in the water. That's probably the type of, you have to have the most care in your surface. In that case, if you're running a cast iron dryer with metallization over the top, you can still get by. You can limp along if you wear down to the cast iron surface. I've seen that done before. It wasn't great. It was
mm.
not a positive thing, but it was, you weren't dead in the water. And with a steel dryer and with a metallized surface, that combination, special care needs to be taken that you're minding the surface and not damaging it by poor doctor setup, hygiene, or incorrect blade material selection.
Okay. Uh, One question. So in my experience, ceramic is significantly more expensive than steel. But can you talk a little bit about cost versus performance? And are there any other things we should be thinking about or be aware of?
Yeah, for sure, ceramic blades, no matter who supplies them, are much more expensive than steel if you're just comparing it blade to blade. Um, and a ceramic blade, though, generally will wear much, much more slowly than steel. So there's a couple benefits to that. One is fewer blade changes due to a blade that is worn to the point that either runnability or sheet properties say I must stop and change the blade. And that's typically where the economic justification is done. If you're if you're changing the blade 2 or 3 or 4 fewer times in a day, that's whatever 5 or 10 or 15 minutes each blade change of additional availability that your machine is gaining, and the value of that production will generally easily outweigh the additional cost of a ceramic blade. So it's about efficiency in that regard. But we talked earlier about these guys in converting.
Hmm.
Am I making their life miserable? And a ceramic blade, because it wears more slowly, or anything you're doing to cause your blade to wear more slowly, means your sheet properties aren't going way down real quick. It's a very slow change, and if you've got a slow change in sheet properties as the blade wears, it makes it much easier to have a stable converting environment. And in the end, if you're a tissue manufacturer that also converts your product, ultimately cases out the door is what makes the company money, not reels off the machine. So the cases out the door is really the most important thing in that case. And you need to pay attention to how your tissue machine is affecting the converting machines, and slower change in sheet properties due to blade wear rate being slower should have a really positive impact there.
Okay, great. Any other stories?
Yeah, the only other thing I would say is, the ceramic is kind of like you mentioned blue steel. I think ceramic is kind of used as a catch-all term, and you can probably argue whether a blade that is CERMET is accurately described as ceramic. Maybe, maybe not, but it's probably important to identify that there are different types of spray coated tipped blades that operate under the catch-all term of ceramic, and that is CERMET,
Mm-hmm.
which is a carbide-based thermal spray, and ceramic, which is an oxide-based thermal spray. So they have different properties, different uses. Some people like the CERMET blade because it is a bit denser and more homogeneous on material on the shelf of the blade, so you don't get that divot as easily, and it's nice for making soft consumer grade products where the ceramic maybe is a little harder. So if you're looking for maximum life in terms of slower rate of sliding blade wear, maybe the ceramic blade will be a better choice then. And there's at least, to my knowledge, there's at least one manufacturer supplier of thermal spray coatings for Yankee dryers, metallizations, that may even prohibit the use of CERMET blades on the dryer because they just want ceramic only, because true ceramic materials are the only thing that is 100% incapable under any condition of micro welding. My argument would be, if you have a problem on your machine that has gotten to the point with a CERMET blade that you're going to micro weld, if you were running a ceramic blade in that condition, you might not micro weld. There's going to be damage done to the surface of that metallized material no matter what. And so it all comes down to operating your machine, properly with the right kind of interlocks that essentially prevent you operating with a blade against a turning dryer without the spray boom applying chemistry to the dryer surface.
All right, that's good. What I'd like to do is shift into operators. I'm sure you interact with a lot of operators in your work, but what do you think separates an average operator from a great operator?
Hmm. That's a really good question. Obviously, in my experience, the great operators are people that have been allowed to spend extensive time on the machine, meaning they started, as a back tender or whatever, or whatever the fifth hand or whatever. They slowly work their way up, and they do each job for some extended period of time and understand it. It can be a real challenge, the world we live in today. There's lots of folks that move up to all sorts of different roles very quickly, and so lack of experience doesn't mean your operator won't be good, but it means that it takes an even more special kind of person to be really above average. But ultimately, it's somebody that cares.
Hmm.
Every good operator of any level of experience I've seen, they care about their machine, they care about their company, they care about the product they're making, and they have been given proper training by that organization. And a lot of those things go hand in hand. If it's an organization that spends time giving their folks some really good, useful training, that is probably going to be a person that sees value in the company they're working for and will be a more, let's just say, more involved employee. Those are really general things, but I think it's worth saying.
Yeah, yeah, no, definitely. I have learned a lot, a whole lot from operators in my career. If you take an experienced operator and they're noticing things on the machine, maybe it's a sound, a vibration, something has changed, but what are things that they notice that young engineers will miss? Have you come across anything like that?
Yeah, I mean, I guess I would just say, in general, the good operator that is tied into the machine they're gonna be somebody that goes out to the machine and is using their eyes and their ears, and and they obviously they have experience and they're paying attention. There's a lot of maybe this is the Gen X in me coming out, but there's a lot of uh, younger folks or less experienced folks um, out there that are making paper from a desk, and the person that is willing to go out to the machine floor and you know from the engineering or operations management side and be side by side with the operating team with during a sheet break or during payouts of any type are going to be people that learn more and are going to be more valuable. And because a good operator is somebody that anybody can learn a lot from, and those that come in to a company thinking that they learned what they need to know from school are not going to succeed, because all you learn in school is how to learn,
Mm.
and you need to it's okay for a superintendent to learn something from a back tender,
Hmm.
because the good back tenders and operators out there that have been doing it for a long time, they may not know the science behind this or that, but they know what they're talking about.
Mm. Uh, that's well said, Mike. I think humility, having a humble spirit, if you will, out on the machine. If you're an engineer learning things, really just anyone is a great lesson for all of us there.
Mhm.
If you had an opportunity to teach every tissue engineer one thing about creping, what would that be?
Hmm. one thing about creping. That is an interesting thing. There's two things that I look at, and they're both kind of mechanical things that I try to teach people with the uh, reference point of somebody with a little more experience. One thing I would say, just in general, when it comes to creping, is you need to take a step back if you're troubleshooting something and look look at the bigger picture of it. A lot of times an issue can be a loose airline on an air cylinder. So don't get too laser focused on the task or problem at hand. You need to step back, look, and evaluate, and kind of take into consider the whole situation. And I guess with creping in mind, you need to maintain your equipment and check the angles, check the levels, check your cylinders, check everything. But you need to do it safely. The other thing, everybody that is involved with creping and Yankee doctors has put their head up there on a Yankee doctor on a machine down day. And I remember many, many, many years ago, sometimes on a machine with a cleaning doctor, you can't access the cleaning doctor without the creping doctor loaded. And the 25 years ago, the way we did that was, I'm going to go up in there, you're going to guard the controls. And that is incredibly unsafe. And people have been killed that way. So what I tell people is you need to not put yourself in an unsafe situation. And thankfully today, companies have developed brackets that you can use essentially to load the crepe doctor and put safety pins in place to prevent it from unloading mechanically. And then you combine that with locking out the unload air on the creping doctor, then you can go safely in on that cleaning doctor and do your work with the room you need to do, but doing it safely. And that's been a thing that I try to leave people with. And thankfully, we live in a different world today where safety of people is now much, much, much more important. And so yeah, being safe and it is a big thing for me.
Mike, I really appreciate you sharing your experience, your wisdom that you've gathered over the years, taking the time to do that with us today. And thanks for being part of our podcast.
Yeah, thanks. My first podcast, and I was happy to do it, Rob. You're a great guy with a great reputation in the tissue industry with a lot to share with people. So I'd be happy to come back anytime and talk to you more.
That sounds good. All right, Mike, thanks very much.
All right, thanks.